Grinding wheel construction and types. This module will provide a general introduction to grinding wheels. It will cover the kinds of abrasives used, bonding agents, the different types of wheels, and wheel identification markings. Man has been using rocks and other natural elements to sharpen weapons and tools since early in his development. These natural abrasives, which include emery, corundum, crocus, sand, sandstone, quartz, and diamond, soon became unsatisfactory for industrial use. This led to the development of other types of abrasives, such as aluminum oxide, silicon carbide, cubic boron nitride, and manufactured diamonds. All of these materials are man-made. One of the first types of man-made abrasive was silicon carbide. Today it is mainly used for grinding non-metallic material. Aluminum oxide is by far the most widely used man-made abrasive, accounting for approximately 75% of the grinding wheels produced today. Another of the newer manufactured abrasives is cubic boron nitride. CBN, as it is frequently referred to, is just slightly below diamond on the hardness scale. Because of its special properties, CBN is often used instead of diamond for grinding. Since diamonds are the hardest substance known, a method of manufacturing them became a prime goal of industry. After much research and testing, a process was developed whereby diamonds could be made. In most cases, manufactured diamond is superior to natural diamond because of the ability to control the shape, size, and surface of the diamond while it is being made. Before a wheel can be made, the abrasive grains must be separated as to size. This is done by sifting them through screens. The grain size, or grit, is determined by the size of screen mesh it will pass through. The next item in the process of making a wheel is the type of bond material used to hold the abrasive grains together to form the wheel. About half of the wheels made are vitrified bond. Vitrified bond is a glass-like material closely resembling that used to make common glass. Vitrified wheels are used for either wet or dry grinding because they are not affected by temperature changes, water, oil, or acid. Approximately 1/3 of the grinding wheels are made with a resinoid bond. The resinoid bond is material similar to that used in the manufacture of handles for cooking utensils. Wheels with resinoid bond are used for rough grinding and fast removal of material. They are a cool cutting wheel. Rubber bonded wheels account for nearly 10% of the wheels produced. Their primary use is for finish grinding cams and bearing races. They can stand shock and are flexible yet strong. Wheels bonded together by shellac are not used very widely, although they do have their special place in industry. Silicate bond wheels are also a limited-use wheel. The final type of bonding material used for regular grinding wheels is oxychloride bond. These wheels must be aged before they are ready for use. Metal is used as a bonding agent for a portion of the diamond wheels on the market. Now it is time to cover the shapes of various grinding wheels. There are two basic types of wheels, the straight or periphery wheel and the straight cup or side grinding wheel. The other types that will be illustrated are all variations of the two basic wheels. The Type 1 straight wheel is the most common wheel and may be used on nearly all grinding machines, which include pedestal grinders, surface grinders, centerless grinders, hand grinders, etc. Another Type 1 wheel is the cutoff wheel. It is used exactly like the name implies, for cutting off or parting work. One of the variations of the straight wheel is recessed on one side, Type 5. This type of wheel is good for grinding vertical surfaces. Other design changes to the straight wheel are recessed both sides, saucer, relieved on one or both sides, combination recessed and relieved, depressed center, etc. In addition to the different types of straight wheels, there are a variety of wheel faces available. A letter designation from A to Z determines the shape of the face of the wheel. A few common faces are illustrated. The basic side grinding wheel is the Type 6 straight cup wheel. It may be used on tool and cutter grinders and vertical spindle surface grinders. A flaring cup wheel, Type 11, is primarily used on the tool and cutter grinder and portable grinders. The Type 12 dish wheel may be used for side grinding and periphery grinding. Cones and plugs are also included in the list of grinding wheel classes. This Type 16 cone threads onto a bushing and is used to grind fillets, areas that are difficult to reach, and for internal grinding. Almost any part of a cone or plug, such as this Type 18 plug, may be used for grinding. Do not use the side that mounts against the threaded bushing for grinding. Diamond wheels also come in a variety of shapes. The actual grinding surface of each wheel is all that is covered with a diamond abrasive. As with regular grinding wheels, the two basic shapes of diamond wheels are straight, as illustrated by this Type 1 cutoff wheel, and cup wheels, like the Type 11 flaring cup wheel shown. The final area to be covered is the standard marking system used to identify grinding wheel characteristics. This information is printed on the blotter or directly onto the wheel itself. The first mark that is common to all wheels, regardless of manufacturer, identifies the type of abrasive used in the wheel. Note, diamond wheel markings will be covered later. Grain size or grit is next, indicated by a number ranging from 10 for coarse wheels to 600 for very fine wheels. The grade or hardness of a wheel is represented by a letter, A for the softest wheel to Z for the hardest wheel. An optional area for rating the structure of the wheel follows the grade. The structure refers to how close the bond and abrasive grains are packed together, dense to open. The type of bond used in the wheel is listed next. Since 50% of all wheels that are made are vitrified bond, you will become quite familiar with the V marking. This last position, since it is optional, will not always contain any markings depending on the company that produced the wheel. Diamond wheel markings are basically the same as regular grinding wheels. The abrasive, of course, is diamond. The difference is whether it's natural, man-made, or coated diamond. The next area is for identifying the grit size. The grade, soft to hard, follows, and is a selected letter from H to T. Diamond concentration is one item that is different from standard wheel markings. The number refers to the percentage of diamond and bonding material used. Since there are only 3 types of bond used with diamond wheels, the letter B, M, or V will follow the concentration. This is an optional designation and may not be found on all wheels. The depth of the diamond abrasive is the last item in the information line on the wheel. This module is meant to give the machine tool operator a brief overview of grinding wheels. It may be helpful in the future when it becomes necessary to select a wheel that will perform best for a given set of parameters.